Here's a picture of a dog running and jumping off the end of a dock. Now, why would the dog do this? This is actually an agility event that dogs compete in, and that relates to our problem for today. Dock jumping is a dog agility event in which dogs run the length of a dock and jump from the end into the water. Prizes are awarded for the greatest distances reached. Dogs that do a flat jump run straight off the end of the dock at top speed. If a dog has a height of 1.2 meters above the water, a typical value, and a dog does a flat jump off the dock at a typical speed of 6 meters per second, how far from the end of the dock will the dog splash down? Well, let's record the crucial information in this passage. First off, the dock has a height of 1.2 meters above the water. That's going to be important for us. And that's about right. That's about 4 feet. And that seems reasonable for a dock. The dog is running and it goes off the end of the dock at about 6 meters per second. And that's a pretty reasonable speed for a dog to get up to over a short distance of a dock. Dogs can easily do that, so the numbers are quite reasonable. There are 2 quantitative pieces, but there's another piece of information that we need, and that's this. The dog is doing a flat jump. And what that means is this. The dog is going to run and it's going to jump just straight off the end of the dock. It's not going to be going vertically at all. Its motion is going to be exactly horizontal when it goes off the end of the dock. Let's take a look at how to solve this problem. We're going to start with a picture that illustrates the full situation. We have the edge of a dock. We have a dog at the edge of the dock, and the dog is moving horizontally at 6 meters per second, and then continues off the edge of the dock. Now, if we plot the dog's subsequent trajectory, it's going to do this. The dog is going to be initially moving horizontally, but then it's going to travel in a parabolic arc to where it hits the water. What we're interested in solving for is this. How far does the dog move from when it leaves the end of the dock to when it hits the water? We're going to call that distance delta x. That's the piece we're interested in finding, so we'll put it here with a question mark. That's the physical setup that we have. To solve this problem, we're going to break the motion up into 2 separate pieces. And first off, I want to think about the dog's horizontal motion. The instant that it leaves the dock, it's traveling at a horizontal speed of 6 meters per second. Here's the question. How does the dog's speed change subsequently? If I was to draw a graph of the speed, horizontal speed of the dog as a function of time, Vx versus t, what does it look like? We'll give you some choices. When the dog goes off the dock, its horizontal motion is completely independent from its vertical motion. So the dog's speed starts at 6 meters per second, and then it just continues at 6 meters per second. And so the graph is just a straight line at the positive value of 6 meters per second. It's uniform motion. And we know for uniform motion problems, we have a rather straightforward equation to solve for them. It looks like this. The change in position is just equal to Vx, the horizontal velocity, times delta t, times the time interval. Well, how do we find the time interval? How long is the dog in the air for? To answer that, we've got to look at the vertical motion. We'll do that next. The vertical motion is just free fall. When the dog goes off the end of the dock, the only thing that matters is gravity. We're not going to ignore air resistance. So given that, let's think, how does the dog's vertical velocity vary as a function of time? Think about that. We'll give you some choices. Initially, when the dog leaves the dock, it's moving horizontally only. There's no vertical velocity. So it starts out with the vertical velocity equal to 0, but after that, the vertical velocity goes negative. And so we have a straight line that trends downward. And we know the slope of this line. The slope of a velocity versus time graph is just the acceleration. And in free fall, the acceleration is negative 9.8 meters per second squared. That's just the acceleration of gravity. Now here's the thing. We're interested in knowing how long the dog travels through the air. That's fixed by the vertical motion, because the dog is going to fall 1.2 meters. Once it's fallen 1.2 meters, it hits the water, and that's the end of the problem. So to calculate the time interval, we need to say something about the vertical motion, and the vertical motion is motion with constant acceleration, and the acceleration is negative 9.8 meters per second squared. And we have an equation for circumstances like this. It's this. The final position is equal to the initial position plus the initial velocity. Now remember, we just want the y component of the initial velocity times the time interval plus 1/2 times the acceleration, and it's the y acceleration times the time interval all squared. And let's take a look at how we're going to solve that equation. We'll think about the values that we want to use. So let's rewrite the equation. The final position is equal to the initial position plus the initial velocity in the y direction times the time interval plus 1/2 times the acceleration times the time interval squared. And we know some things about this equation. We know the initial velocity is equal to 0. So that tells us this term goes away. There is no y velocity initially. We also know the initial position. The initial position is the dock, and the dock is 1.2 meters above the water. So let's let that be 1.2 meters. The final position is at the water, so the final position is 0. And we know the acceleration is negative 9.8 meters per second squared, because gravity is the only thing we need to consider. So with this, we have everything we need to know in the equation, and we can solve for the time interval. And if we do that, we get a time interval of 0.49 seconds, half a second. And that seems reasonable for a fall from that height. And that is a piece of information we'll use in the next part of the problem. Next up, let's look at the horizontal piece. The dog was moving 6 meters per second horizontally when it left the dock. That motion will continue. So the horizontal speed, Vx, 6 meters per second, continues. That will not change. And that motion will continue for the entire time that the dog's in the air. But we solved for how much time the dog was in the air. That's 0.49 seconds. So the distance the dog will move is just equal to the speed, that's 6 meters per second, times the time interval, and the time interval is 0.49 seconds. So that tells us that the dog travels a total distance of 2.9 meters. And to put that into units that might be more familiar to you, if we convert that to feet, that's 9.5 feet. Next up, we're going to look at that answer and see if that makes sense. The dog is moving 2.9 meters through the air, 9.5 feet through the air before it hits the water. How does that work in real life? Let's take a look. How do you get your dog to run straight off the end of a dock? Here's what you do. Take your dog out to the dock and you throw a toy. And the dog will run to the end of the dock and just keep on going into the water. That's how you get a dog to do a flat jump. How far do they go? Well, the dog is 4 feet off the water. Dog goes out about 10 feet. Thinking about how fast the dog's going to be running, that seems reasonable. Now, in fact, the world record for dogs, some dogs can get up to 20 feet. Other dogs can get close to 30 in this event. What they need to do is not go straight off the end, but launch themselves. That takes a little bit of training. But the numbers look about right, and you can see physically how all this would work. Not a surprise. Physics is about the world around us.